Welcome everyone. Welcome Paul. We're so excited. We have another webinar, Making Maths Fun. And today we're going to talk about tens frames. I've got my tens frames, Paul. Do you have yours?
I have several of them, so we'll be able to join two together in this seminar.
Fantastic. I look forward to, we use them a lot. I've used them a lot for adding, subtracting, and number bonds, all sorts of things. So I look forward to seeing how I can extend my knowledge with the tens frames. I'm going to hand over to you, Paul.
Thanks, Heather. And look, essentially, we're just going to look at the focus of a tens frame and some of the key ideas that sit under it. And I'll make that sort of a bit clearer as we go. But what I'd like to do is just focus you for a moment just on this idea of the tens frame itself. Have some extra teaching material that's useful for people and so forth. But I just really want to start with a couple of ideas. And one of them simply is, I suggest there's a progression. And so the progression is really going to head from the idea of what I'm going to call a 5 frame, then a 10 strip, and then a 10 frame. So if you just have a look, I've got an example of that. So the 5 frame is pretty obvious. It's like a half a 10 frame. Works nicely. And for young children, we'd look at all the variations up to 5, counting up to 5, putting 1 on there and so forth. Or maybe there's 3 counters on there and how many more to make 5 and so forth. The advantage of the 10 strip, it's about the length. The 10 strip is really giving the idea that as numbers get larger, it gets longer. So in other words, a 9 is larger than a 6. It goes further in the length. Once you've got those two key ideas sitting inside your head, then it's not that much difficult then to move on to the tens frame. So that's what we'll look at and focus on today. But I just thought we'd just get those couple of ideas. So very early years, we'd use the 5 frame, build to the 10 strip on that length idea, and then we'd head to what we're going to play with today, which is the 10 frame itself. Now I just wanted to make a couple of comments, and I'll show you some up on the board here in this sense of an idea. So there's our 10 frame that we have. You notice that I've used 2 different colors of counters. The 2 colors don't matter that much, but most 2 color counters will be red on one side and maybe green or yellow or blue on the other side. But I always like to stick to 2 colors. Now, if you don't have two-sided counters, it doesn't matter as long as we're only using 2 colors. So we might use red transparent counters and blue transparent counters. It just really helps to highlight a couple of ideas. And so you notice in the example I've got there, you can see that the whole, you can see there the whole is 10, and essentially one part of it is red, 7, and the other part is 3. And so the notion is what they call part, whole understanding. And that's the key to building, for example, word questions in mathematics, particularly in addition and subtraction. So in this case here, I might say something like, I have 7 lollies, and my friend gave me 3 lollies, and altogether I have 10 lollies, or how many lollies do I have altogether, and so forth. But another question might be along the lines of, I have 7 lollies, and my friend gave me some lollies, and now I've got 10 lollies. How many did my friend give me? You can see it's the 3 that sits there, and that's why I like the 2 colors essentially. Now, one other little comment I'll make is that there are typically 2 ways that you can fill a tens frame. So sitting inside here, we'll have a look at this 5 frame idea, and I'll just take us back into there so you can see it in a little bit more detail. You'll see that you can also have the bit about the 5-wise way. Can you see how at the top we just filled? So if you have a look at the top of that 10 frame, we fill the top 5 first, and then the next bit in the next deck. In fact, if we called it a double-decker bus, we'd fill the top deck of the bus from the left across, and then we get the bottom bit. In a pairwise, we're filling pairwise from the left, and you see how they look a little bit different. And there's a reason for each one of those. Typically in calculation, we'll use the 5-wise, where we basically what we do is we show the top deck of the bus first, and then we build across that one and so forth. So they're the 2 typical ways to do it. And for most of this presentation, we'll just use the filling the top of the double-decker bus first, the 5-wise system and so forth. Now, just to take us a little bit further, I'll show you what I mean when we're filling these up, and so you get a bit of an idea. So I've got my 10 frames here. Look, you can make a tens frame from writing on paper, but ultimately here, we're just going to put our counters on, and you can see here that I'm filling my top deck of the double-decker bus. So I filled, and that's where you get the 5. You can see the 5, and that's why we would have built 5 frame first. And then I've got the 7. And this is where I like to be able to just turn the counters over. In this case, we've got red and blue ones, and you can start to see that how that gives me the 10. As I said, the other way to fill it up is to work from the left across, and we'd work in pairs. So in this case here, so you notice that I work in a pair there, and then a pair there, and so on. Now there's advantage of each method, but let me explain a little bit about why they're the case and so forth. All right, so if we have a look here, I'll take you back onto the PowerPoint. You can see, and I'll just take us down a little bit here. And you see here, for example, a bit easier to see at this sort of spot here, you can see that when I go in the pairwise sort of approach, you can see why it's obvious that when I add an odd number and an odd number, you will get an even number, because when I join those two together, there's no bit sticking out. When you have odd numbers, a bit sticks out, which is the pairwise thing, and it shows us that. But let's move on a little bit so we can sort of a little bit more focus on the tens frame itself. I just wanted to give that a little idea of how they sort of develop and the uses of it. So one, it would be, for example, we'll just go to the straight tens, and I'll just take you down onto our piece here, and we can have on our visualize. I'll just use the straight 10 frame. Now one would be, you might use something like a 10-sided dice here, and I might roll the dice. And imagine, for example, I've just rolled 6 in this case here. And so then I might fill this, and we're going to fill the top deck first, because we'll use a 5-wise system for this. Just helps a little bit the calculation. I've got 5, and then I've got 6. And the question would be, how many more is it to make the 10? Now, if I was linking this to word type questions, it'd be along the lines of, I have 6 lollies. My friend gave me some lollies, and now I've got 10. So now I've got to work it out. Now some children will be able to see the 4 blank pieces in here. Others literally have to count on the 4 to work that out. So a very simple idea is just literally to roll dice or use a spinner and so forth to do that. And basically what we're then building up is this idea of things that add to 10, which is pretty fundamental. So we're building the tens frame. The obvious bit is the whole is 10, and the bits that go together to make 10. So I'll give you an idea. So if you want to, I'll just take you onto slides so you can see what I mean. So in this case here, we've got the idea of rolling. How many more to make 10? We roll the dice. We could use a spinner, and essentially the same sort of thing, and we ended up with the 10. Now, if you want to go on my website, you can download a game that's called Build to 10, and that's the same general idea. In that case, you just use a spinner. You put that spinner template on, you spin it, it might spin up 7. So you've now got to put the counter on whatever builds it to 10. So 7 and 3 more builds it to 10. So you can start to see how you got this general idea of the things that add to 10 and how they work together. And that's a fundamental idea for anything goes beyond 10. So we work from the 5 frame, the 10 strip to the 10 frame, but now we can take it a step further and see how the 10 frames, when they're built, in other words, when they've got all the 10 counters in them, how they build to other sorts of numbers. So I'll give you an example of that. We're going to put 2 together, and I'll just take us down here. So I'm going to take one 10 frame, and I'm going to put a second one. So now what we're doing is building 2 10 frames together. And when we do that, we can do a thing called bridging 10. Bridging 10 works nicely when I'll put an example here. So we're going to fill this one up. And after a while, you get to recognize very quickly how to fill things up. And we're going to fill it up with 9 counters. Now, 9 counters is pretty obvious because it's one less than 10. So it's easy to fill. So in this case here, imagine that we were doing something 9 and some other number. Now I'm going to use different colors here just to make it nice and clear. So in this case here, the calculation that we will have is 9 and 6. Okay, so now I want to add 9 and 6, but I can't actually bridge the 10 because we've got a piece missing in this point here. So it makes sense to bridge the 10. So now that's full. And so 9 and 6 becomes 10 and 5 or 15. So there's the other notion here that we took the idea of things that add 10 and then that allowed us to bridge over the 10. So even numbers like 8 and 7 would be 8 and 2 more is 10 and another 5. And the 10 frame gives you a really nice focus on that sort of idea. But now I'd like to just sort of share a little game idea. So Heather, I want you to imagine at your end you're playing against me and you've got two 10 frames that are linked exactly like that. Now, I'm just going to play, but I imagine that I've got someone playing against me, and I'll show you how it works and we'll play together in this sense. So we'll head back down to the down to here. Okay, and once again we're going to start at this point here. Now the key part about what we're about to do right now is the mathematical language that goes with this. Now I'm going to use, in this case here, a four-sided dice as the numbers 1, 2, 3, 4, but you could use a 4-part spinner to do the same thing. And just imagine that I've just done a roll. Now the way you read this sort of four-sided dice is you read around the base. So for me, that's actually come up as a 3, okay, and I'll put 3 counters on, and I've got 1, 2, 3. Now we're racing to 20, and so imagine, Heather, you've just had a shot, and it doesn't matter, you would have got a 1, 2, 3 or 4. That would happen here. So we got two players sort of playing side by side, but we're racing each other to 20. So I've had a shot, Heather, you've had a shot, and now in this case here, a roll again, and imagine in this case I rolled a 2. That's a bit rigged. I hope you didn't see that one, Heather, but I rigged that one there. And notice what I've done. I've just turned this over. So you see I've changed the colour. And I'll explain why as we go a bit more. Now I just had another shot. That was really good. I got a 4. It's like I'm playing with my grandchildren. It's amazing how often big numbers come up. Play with them. So it's 1, 2, 3, 4 goes on there. And now what's going to happen is I roll again. Now you've already had your shot, Heather. So I've had 1 shot, 2 shots. That's my 3rd shot. Hopefully you've had 3 shots. And now I'm rolling here and I've got a 1. That's a bit of a fluke, but there it is. It happens to be I got to the 10. Now I'm going to stop there just for the moment, and I want to just talk this through a little bit. I like children to tell me the story of their game. And by that I mean here, so what happened in this game? Well, I rolled a 3. So you can see why we're starting at the left-hand side here, the top deck of the bus. Okay, so just to give you that idea that sits in there. Okay, and I just want to take that general idea and I'll just take us through here a little bit and hopefully you'll get how it works. Okay, sorry, it went the wrong way then. Okay, so at this point here, I rolled a 3, then I rolled a 2, then I rolled a 4, and then I rolled a 1. So 3 and 2 is 5, and another 4 is 9, and another 1 is 10. Now I could write that as an equation. So we'll just head down there and you see exactly what I mean when I say we could write this as an equation. Essentially what we're going to do is put the numbers and make a number sentence, okay? Probably equation's too big a word. So in this case here, what I'm going to write, I'm going to write 4, oh, it's 3 in this case, sorry about that. So we're going to write 3 and 2 and 4 and 1 equals 10. So you start to see that what I've got there is what happened in the game. We did a 3 and then a 2. You can see it here, a 4 and a 1, and altogether I've got the 10. Now I'm not sure how far you're going at the moment, Heather, but I'm going to have another roll at this point, and I just happen to roll a 2. There we go, there it is. And now last shot was blue, so I'm going to put 2 red ones here. Okay, just so happens where we go here, this is a bit rigged. I'm going to roll a 3. Okay, and now I'm going to have 1, 2, 3. Now we could have the story of our game. So now let's think about the story of the game is. Once again, well, I rolled a 3, so I can write the equation or the number sentence. So I rolled a 3, and then I rolled a 2, and then I rolled a 4, and then I rolled a 1, and then I rolled a 2, and then I rolled a 3, and we can see that we're actually got to 15 at this point here. And so you start to link what's going on here in terms of the physical use of the tens frame, and then we link it to the equation or the number sentence that's happening there. Now we'd roll and roll and roll, and unfortunately, Heather, I won. Okay, so sorry about that, but that's the particular case here. In that one there, yes, you haven't kept up anywhere near as much as me, but you'd play and you'd race to 20. But I like to introduce that idea. First, we play with the counters, but you can see there what we've done is linked to the numbers, writing the number sentence or the equation that happens there. So I'm trying to link the physical, the concrete materials there to the written or the abstraction that would happen. Now, games of race to 20, pretty easy to play. If you don't have a tens frame at home, all you need to really do is, if you've got egg cartons that are in 12, you cut 2 off the end, so it's 2 rows of 5, join 2 together. You could use stones or anything, maybe marbles, anything could go in there. You roll the dice or you use the spinner. Now, if it's useful, we'll make the slides available and so forth, but I'll bring up on this case here. So we've got, in this bit here, we've got a little 1 to 4 part spinner that would sit there, a little bit of explanation how to play the game. And if you basically got a paper clip and a pen, then you're able to show that sort of thing there, and you can make your own little spinner. So some people want to play at home, they can play this little race to 20 game and so forth. All right, so hopefully that makes a bit of sense there, but let's just take it a little bit further. So essentially, we've got a pretty basic tool that sits in there and it builds us to 10. But the reason we want to get to 10 is because of a thing called place value. And so what I want to just show you is how we might then take it a step further into place value. So once again, we'll go and have a look down on here, and I'll make this little comment. So at this point here, I'm just going to turn my 10 frames around like this. And you can see now that what I've got is one group of 10. If I turn this around, I could have 2 groups of 10, and I'll fill them up with the counters. I'm trying to stick to the same color. So now whatever we're going to do from this point on is 20 something. And because the next one is not 10 at all, so we might have here 21, 22, 23, and you start to see all I've done is turn the 10 frames on its side, and that starts to represent the 10s. Now, that's no different to, say I was using something like base 10 blocks. I might have the little unit cubes, but when I get those longs, I can turn them around and so forth. So it's a bit similar in this sort of idea, that the reason I just turn them around is just to make it very clear that we've got the 10s and the 1s. So you'll notice that if I just take you back here, we can see the 10s are sitting here, the 1s are here. If I had another full set here, imagine that was full, then it'd be 30 something and so on. And so we can also use the 10 frames to develop that sort of place value understanding as well. So that's why I quite like 10 frames, because they're really versatile, and they build, as I said, that part whole sort of knowledge. So just to give you an idea, I'm just going to put one up on the screen just for you to look at there. So in this case here, we've got this bit about, okay, so there's our 30 and there's our 2. And so children start to be able to recognize those configurations. In this case here as well, after a while, when you recognize this, you don't need to be able to move the counters around. So you can actually create a set of cards that have 10 frames filled in, okay, and that'll be all of your 10s. And then all you have to do is play with what the 1s or the units might be in that case. So, and that's why you often see, for example, 10 frame cards that are already pre-made, because we don't need to fill them up if they've already got 10 in them, and that's making that general idea. So there's a bunch of card games, for example, you can play with the 10s frame as well. So that's just sort of giving some ideas of that sort of thing. I just think it's such a versatile resource. You only need counters. As I said, stick with 2 colors, makes it much easier. Start with 1, or start with a 5 frame, the 10 strip, the 10 frame. Then you notice that we built 2 10 frames together, and then we turn them sideways and we got the place value. And that's what I like, is it's a simple resource. Now, just a couple other comments. If you're looking for sort of more information on how to get the maximum value out of the materials you might already have in your school, or you're looking for how to, what tool fits a particular idea. So in here, what we've done is we've used the 10 frame for adding numbers and so forth, for doing the number sentences, and we've used it for place value. Then I'm going to suggest that there's a spot you might like to go, and I'll just bring it up on the screen. Okay, what we've been doing is producing a simple website. It's really just called Maths Materials, and you can see that's not even the full range of materials there. And on each page, we give like 2 pages explaining, the common uses of that tool. We've been explaining some of the language you might use when you have that tool, and even things like the videos that we've been making over the last year or so. What we're doing is now putting them into that spot. So essentially be a repository of, on how do I use the 10 frame again? I can whiz in here, find out very quickly. It might be that there's a few of these support materials or sheets that we've used in the last year or so. And what we're trying to do is just make it a one-stop shop so people can find out about the materials. One that might already be in their storeroom, but also if they're thinking about getting others, what are the more versatile ones? And you notice that, how versatile is the TENS frame. So hopefully that's a bit of a focus there. If people want to try and use the TENS frame, and they're in schools everywhere, but they're fairly easy to use. So sorry I beat you today, Heather, but maybe when you play your children next, you might beat them in race to 20.
Thank you so much, Paul. Do you know what? I think I might have beat you because I think I raced beforehand. So I was actually racing through while you were doing, while you were playing. No, but thank you so much, Paul, making maths fun, engaging, breaking down the strategies and the games for everyone. You're right. The TENS frame is very visual, simplistic, but really effective. So I know when you did that odd, you actually visually put it down in front of a child, you can actually, they'll see, they can actually see with the two colors as well. So the maths material website is amazing. I was looking at the cubes the other day. So I was you put up a whole lot of videos on the cubes. So thank you for that. This Making Maths Fun will be available on both YouTube channels. So EDX Education and Dr. Paul Swan. So we look forward to seeing you. Thank you very much, Paul. Take care.
No worries. Thanks, Heather. Bye.